All right, folks, so those of you who are just joining us, thanks for being here right on time. We're going to let people kind of trickle in a little bit, get the numbers up, and then I will hand it over to Chuck. Over the course of the class, if you've got questions, please, you'll see, I'm not sure where I am on your screen, but probably here-ish, there's a Q&A field. So please put questions in the Q&A area, and then other folks, if you're looking for questions and you see something that you want to be responded to, you can upvote those questions, and then when there's a natural break in the class, those can be addressed ranked rather than just the most recent question to be asked. So we'll hang out for a little bit, let the numbers go up a little bit, but thanks everybody for being here. And thanks Cineo for this mug.
Looking forward to it.
All right, so it looks like the initial folks, the numbers stopped going up for now. So I'm sure more folks will come in kind of as the class carries on, but Chuck, I know you got a lot to get to in an hour. So I will pass it over to you.
All right, very good.
Thanks so much.
Are you going to be able to put my screen up?
Yes, sorry, give me 1 second. Yep, so you can hit, you can do share, you should be able to do share screen now.
Great. Very good. Does that look right?
Yes, sir.
Very good. All right. I'm Chuck Edwards. For those of you who don't know, I was CTO of Cineo Lighting until about 1.5 years ago, at which point NBC Universal actually acquired Cineo Lighting. So Cineo is now a brand of NBC Universal and NBC Universal company. Recently, over the last 6 months, we've been not only developing lighting, but network stage solutions. How do we network all the lights together and the environment together on stage, as well as looking at virtual production and the challenges and opportunities that presents. So as we start off this discussion, the first thing I want to talk about is virtual production is actually a natural evolution of what we've been doing in film for decades. I mean, since early projection in the days of black and white film until now, it's just been a constant progression. A film I think that's sometimes underappreciated was Oblivion, done in 2013. Claudio Miranda was the DP. In this film, he wanted to have this beautiful apartment up in the sky. And the question is, how could you have all these modern reflective surfaces and achieve a realistic effect? And so they were very ambitious, and they set up, and some of the people we work with closely were involved in this. They set up a huge projection screen and did what I consider one of the first large-scale virtual production sets. And it really was a beautiful, really beautiful production. And then from there, we know about First Man and Gravity, doing the same kind of thing with LED walls, and also Murder on the Orient Express. But I think the one that's really grabbed people's interest recently is Mandalorian. And so I see that as an extension of the massive technology migration we've seen over the last 5 to 10 years, specifically in LED. When we started out developing LED product, our first product was called the HS, and it was a high-powered LED light, and we thought it was really cool that using remote phosphor plates, you could change the CCT. And at the time, people were like, that's crazy, you could buy one light source, you could change the CCT, who'd want anything more than that? And of course, very quickly, we ended up having to develop a bicolor fixture where you could shift the CCT with a DMX command. And that was the Quantum, which I'm sure a lot of you probably had experience with that. Then in 2017, we had to come out with our full color. The industry was clearly moving that way. Followed by that, we went to zone color in 2017-18. Now all of our fixtures have color capability. And this last year, we've introduced, all of these lights are typically soft lights. This year, we saw a need for a digitally tunable hard light, and we came out with ReFlex. Now, ReFlex required some significant breakthroughs to get us that level of lighting control in a hard light fixture. And so we'll talk about that next. But the cool thing here is all of these individual LEDs are actually digitally controlled. One of our challenges, and we're working on this in our new software, is there's actually 6 sides times 9 zones. So we have 54 total LEDs, each with a warm and a cool white. So we actually have 108 different zone / modules that we can, light modules that we can control. The reason this is exploding in capability is because the LED turned lighting from an analog instrument to a digital instrument. And that's similar to what happened with cameras. As soon as cameras went from being analog to digital, all of a sudden the controls, the things you can do, just exploded. And it's true of any technology in the past, from telephone to television to any device. When you move from being a analog device to a totally digital device, now you're computer controlled and you can evolve. The next evolution we see is that the lighting and LED panels are really one and the same technology. They're driven the same way, use the same core technology, and their goal is the same. Their goal is to create an environment that enhances the story and performance. It used to be all we could do is create shadows and a certain CCT, and then we got so we could add color to the environment, and then we could add motion, and we could add moving color, and now we're actually able to add content in the form of lighting. I want you to consider the size and the challenges of these type of environments. Based on the information we have, is a Mandalorian size volume set is going to be 75 feet in diameter, 20 feet high. It's going to take nearly 3,000 panels and be over 700 square meters in size. The weight of the panels alone before rigging is over 14 metric tons. Smaller stages are being considered as well. And we see the digital lighting, the LED lighting, and these environments are going to work closely together. And the reason being that these stages tend to provide only soft light. And so you want to have hard light, and you want controllable light, and you want to add color effects. So we're seeing an integrated approach longer term as we move these technologies together. I want to talk a little about ReFlex and why we developed this fixture for these new environments. So the key is this array of LEDs. The array of LEDs is actually 9 what they call chip scale packages. So the problem with getting a bright LED light is, first, how do you get the LEDs close enough together that you can have a small source? So what we had to do in order to enable this is go from normal packaged LEDs, which are discrete, and turn them into what they call chip scale package, which is they don't even put the LED in a package. They mount the LED directly onto the substrate. And in this case, it's aluminum nitride. And so we have 9 substrates per side. There's 6 sides total. And each substrate alternates between warm white and cool white LEDs, 27 to 65. Each of those is controlled by its own separate driver mechanism. So the second problem, and usually the bigger problem with LEDs, is how do you cool this? How do you possibly get that many LEDs in that close to space? And LEDs, their kryptonite is heat. If LEDs get too hot, they burn up. And I can tell you that we tried numerous different methods to cool these LEDs, and several of them resulted in smoke and flame, then flare up. It takes one of these devices about 3 to 4 seconds in open air, if it's not heat sink, to burn up. It's that kind of power. So the way we solved it, after reviewing a bunch of different methods, is we actually pump a coolant through the center of this tower, and then it flows back over the top of the LEDs. So it's called immersion cooling. We didn't invent that idea. It's been used for large servers, and if you buy a gaming PC, some of the high-end gaming PCs where they have to cool the processor, they also use liquid cooling. What we did differently, though, is the liquid that we use is an insulating liquid. It's called dielectric, so it doesn't actually conduct any electricity. So we use it as an insulator and actually can pump it around live electronics. It doesn't cause any damage. And then the second thing is optically clear. So we actually allow the light to pass through the LEDs. So the big benefit here is we can have the liquid flow behind the LEDs and over the top. Normally LEDs can't be cooled from the top as well, right? They're just in air. And so it provides much, much better cooling. And as a result of that, we can get an extraordinarily bright source in a small location. The second thing we did, though, is we wanted to control the beam. So this top part of the unit is actually in the focal point of this parabolic reflector. So when you light only the first three zones, you get a very tight beam. But as you want to spread the beam out, you light farther down the tower. And as a result of that, you've got the ability to go from 15 to 70-degree beam angle with this tool. And here it just shows this is the cooling fans and the radiator that provides the cooling for the tower. So this is how we were able to develop a hard light with beam control and CCT control that's reasonably compact. So now I want to introduce you to the work we're doing on taking these digitally controllable lights and putting them into virtual production. So in order to do this in a timely way, I've compiled this beforehand. So I'm going to play this, this demonstration of the different tools we're developing to bring lighting controls into virtual production in previs.
So the first step for us to put together a stage model is to capture the stage in a program like SolidWorks, an engineering program. So what we did here is we basically captured the supports and the main walls of stage 33 and where the staircase was. Now the way we can verify this, the way I verified it at the time, is I actually just took the PDF drawing off of the website, including where the staircase was and fire lane. It gave me a nice reference. It says it's 25. Now, if we have better, more detailed drawings, of course, we can make a more accurate duplication of the stage. In addition, we wanted to put in perms. So here's the picture of the structure when we added perms and space in the top. Again, this could be more detailed. I just did this as an example based on the drawings. And again, I could render this as the final building. So this is the building we developed to simulate stage 33 in Unreal Engine. Now what I'm going to do is I'm going to take this file out of SolidWorks and now I'm going to move it or import it into Unreal Engine where I'll get the same representation, the same shapes. All right, we're back, but now you'll notice things look differently. And this is because now we're in Unreal Engine. We've imported the stage, we've imported the R15 model, and then we did a lot of work to it. We actually had to program in behaviors and controls. There's a bit of development to turn a simple wire mesh shape into a functioning model.
So one comment here. In order to make this model accurate, we had to import the IES files. If you know what IES files are, is they're the pattern, the beam pattern at different power levels. So the first problem we had is the ReFlex model itself is like 50 megabytes. It's massive. And so we had to dumb that down, and that's what we did up here. You'll notice this is the same basic shape. If you drop accessories in it, they'd fit, but we simplified it quite a bit. Then the second thing we had to do was measure every beam pattern and convert it to an IES file, and that actually becomes, in Unreal Engine, we call it a texture. So when you're playing with the light inside of Unreal Engine, when you see me broadcasting on the wall on Talent, that's the actual beam pattern we would see in real life.
You notice the stage looks different as well. The lighting, the shadowing. And that's one of the strengths of a gaming engine, is its ability to render an environment that feels real. And that's its big advantage as a previs tool. So that said, we've got talent that we brought in. We've got a single truss, so we had something to put the light on so it wasn't just floating in space. And the rest of it really is just those two components. So now let's hit play. Now what that is gaming engine. Of course, when you start filming or capturing the scene, it's actually the play function. Now we're looking at our talent through the camera. I can maneuver the camera. We can look around. What I think I'm going to do is go back towards the staircase so we get a better point of view. And now we'll show you how the light works. So the first thing I do is I select the light and its controls pop up. So I'll start to tilt the light, pan it to our talent. And then I'm going to look at the beam. I can make that a small beam or a wider beam pattern. The other thing I can do is I can shift the CCT. Make it a warmer light or a cooler light. So this shows you how the controls would work. We can group lights of the same type, so we could have a string of them, which is very common when rigging a larger show. So this is the basic process of bringing in a light, modeling it, and bringing in a stage. And now what we're going to do is we're going to actually build a set and show you what you can do with these kind of models. Welcome back to stage 33. You can see we've been busy. We've built a new set inside. You'll see we've put up truss work. We've put up 3 different types of lights, standard 410s, space lights that we've made with reflexes, and then traditional reflexes, all of them with full control. And we've put up a translight. The rest of the stage asset has stayed the same since our last viewing. Let's go inside and see what we've got on the stage. Now what I wanted to point out is the thing that's different about Unreal Engine is these aren't just images placed together in a collage or a pattern. These are actually full 3D models that are then wrapped in what they call a texture. As a result of that, we can light, manipulate, and view the full stage with all of these objects, and the objects become assets, props that we can then put into other scenes and other sets. As a result of that, as we light these objects, as we move them or modify them, they render as if they really are physical objects. That being said, let's go to the first scene. What I'm going to do now is load a preset. All the lights are on 100% now, so this doesn't look very cinematic or interesting. So we want to do more than just preview what the construction would look like. We want to preview how it would look if we lit it properly, chose camera position, blocked the shot.
One comment about this part is that the controls you're seeing is part of the development we're doing internally to add lighting control. So you're going to see on all of our new products that we're putting digital lighting control panels on every light itself. There's going to be a touch screen and and digital software that allows you to do these adjustments. You can also run it obviously over DMX or Ethernet. But what we added in this, and you'll see at the end of this demo, we've added lighting controls. We're just prototyping this, lighting controls that you could operate inside of Unreal Engine while you're previewing that then will physically control the lights on stage. So one environment can be used to previs and do active lighting control.
We've limited depth of field. So our actor on the left is in focus, our actor on the right is out of focus. I can shift that. Just now he's in focus and she's out of focus. I can change the aperture. The whole scene is in focus. I also can change the lighting. So now I'm picking the room lights, and you'll notice I can increase the brightness. I can change the color temperature, make it cooler, make it warmer. I can even introduce color. Let's go to another treatment of the same scene. Here I've taken a night look, changed the perspective to just outside the window. We can zoom out. We can move around the scene and choose a different perspective. Basically, we can treat it just like a set. Now I'll go to the last treatment of this particular scene. Now in this particular scene, we've been using a cityscape as a translight. Let me travel in, I'll show you what I mean. So here's the scene from inside. Now what you can see is we actually have a different perspective. You can see that we're using a cityscape in kind of a twilight situation. And now we'll load a completely different scene where we've moved the actors, we've moved the camera. Now you notice here we have different talent. We've rearranged some of the furniture. And the biggest change we've made is we've replaced the translite of a city with an oceanscape. And this is actually an active video, which means we need to use either green screen or potentially LED wall to display that content. Here we have it appropriately lit. Daylight scene, bright light from the outside, and a little different perspective on the inside. I like the reflections on the floor. It did a nice job. Let's load a different treatment. Here we've gone for an evening look. Notice we've used depth of field in order to blur out the table that's in front of us. I could shift the aperture so that all came into focus. And of course, like before, we could change our camera angle. And compose a different shot. Blur the background more to focus more on the talent. That's just an artistic decision.
By the way, we see this as a lot of people talk about virtual production. They're always talking about kind of Mandalorian volume type stages. We see what we're showing here is actually the part of the iceberg that's under the water. Think of how many episodic shows and commercials and things. They just want to show, outside the apartment, outside the restaurant, the New York street or the fire station or something going on outside. And they want it to be, so this is a great case for flat virtual production screens. And then the advantage of having the lighting, the virtual production, or the LED walls integrated is this type of previs, where you can actually pull the whole thing together, check the placement of your lighting, get an idea of how shots are going to be blocked, how the lighting is going to be adjusted. It's a lot easier to do it in a program than it is to do it physically by moving things in a rig. And so the goal here, of course, is to get not only just a better product in the end, a better production in the end, but to make it easier to try things out without the cost of actually doing it on set.
And here we're going for more of a darker night look.
What we're going to do now is show you how the real lights actually respond in coordination with the controls on Unreal Engine. So with this, I'm going to show you we've got an actual standard 410 in the background.
Note about this. So if you're familiar with Unreal Engine or not, only recently have they put a lot of time into focusing on how do we control light. So in release 4.25, which is May of this year, they added a DMX plugin. And by the way, Unreal Engine is free. If you want to load it on any computer, you can just go to the Epic website and it's free to install. But the cool thing they added was ArtNet control, ArtNet ASSEN control through the same computer network that the virtual production is running on. So we didn't actually have to develop this interface. This is just running Unreal Engine with the DMX plugin in. We were now able to actually talk to our physical lights at the same time.
Let's start making some changes. So Kurt, as you're driving, if you would just move the dim and show the dim changing on the engine and showing it changing on the light at the same time. Now, of course, in Unreal Engine, this isn't the only light on the set, but you can see the impact it has. This is actually controlling the 3 lights on this particular floor. And then if you change the saturation, just to exaggerate it, let's change saturation to 100%. Very good. And then let's just go through the rainbow, let people see the effect it has. So you'll see on set it's changing, or on Unreal set it's changing the same as it is in the environment.
Okay. Before going to the next one, so that is what we consider to be the most kind of basic entry level into virtual production. Having an LED screen that you put on the wall, and then you can shoot an environment where instead of having to be in the real world, you can of course build it all on set, then have a virtual plate that you play, and then light around it so that the two match. Now, the big challenge with the LED walls when you get to bigger environments is they do tend to make everything a soft light. And so part of the problem is if you're trying to do an outdoor scene or something that has hard shadow, you have to introduce stage lights. You have to introduce things like a reflex hard light in order to get those shadows. Even though it's a sunny day outside, the LED wall, the effect is that you get just one huge soft 360 light source. And so there's never going to be a world we see in the future where you won't continue to have stage lighting combined with LED wall content. So if I pull up the next production, this is where we actually built a model of a 50-foot diameter volume stage, and using mocap, so using a motion capture system, you can actually track where the object is where the camera is in the stage, and then if you have a three-dimensional model, you can actually model parallax, which means you can change the aspect ratio of the objects in the background. That's what we'll show you here. What we're doing here is we're creating a virtual stage. This is a virtual 3D asset. The objects in the background render as as you move position of the camera. And then these are the light models we developed so that we could actually change the lighting of the stage. So you'll see the vehicles are changing color, the reflection of the vehicles changing, the color on the talent's changing. I'm decreasing dim, changing saturation. This is a 50-foot by 20-foot stage. So this is inside of like a 100-foot stage, 35 feet up. So the idea here then is that you replace the hard stage mostly with digital assets. The car in this case would be real, and of course you'd have some level of props. The lighting, of course, is needed to get the hard light to do to light the talent and to create shadow. So the challenge of these two environments is it's massive. It's the assets are massive. So I'll pull up an example. So part of the challenge of any of these projects is not only having the lighting and the software interface, but deciding, are you going to move the camera? Because the camera can rotate, you can tilt, you can pan, you can do any of that without changing the parallax of the background. But as soon as you decide to move the camera forward, back, any dimension in X, Y, and Z, you have to re-render the background unless the background is so far away it doesn't matter. And so that effect, that parallax effect, is what makes it necessary to go from 2D plates, even if it's a 360 image, you have to go from two-dimensional plates to three-dimensional models. The technique used for that is called photogrammetry or LiDAR. There are two ways to capture three-dimensional models of an environment. And I'm going to pull up one of those models here. This one was done, I believe, with photogrammetry. That's where you take a drone and you fly around a facility and you take literally hundreds of pictures, and then the software combines it. Now, the cool thing about this type of model, and in this case, is an old abandoned German factory, is you can do things like come up and I can actually change where the sun is. Now I'm going to leave the inside of the volume and fly around, let you see where we're at. So here's the camera, and here's the we're actually inside the volume. So in this type of environment, you can actually, so that would be the size of a volume stage inside this scan. And the detail is pretty impressive. This is an asset that I actually added to the environment so I can move the cars. As you saw, you can change the lighting. So this is a combination of 3D modeling and photography. So the system has to actually map the 3D shape of the object at the same time that it takes pictures of the surface. So it's actually wrapping the outside into texture. Now, the reason why this is so helpful is if I have this type of model, when I come into the space, I can actually light it. So now I'll hit play. Open up my controls, and I can select the light I have. Now, if I have this light, I can increase the brightness of it. I can change the CCT. If I exit, I can actually turn it into more of a nighttime scene. If I want to have the sunset a bit. So the idea is that in this type of environment, the lighting and the virtual production really is kind of a seamless interface for composing the scene. The other cool thing is you can actually control the camera as well in the simulation. By changing the aperture, I can go down, I get the effects of depth of field. So I can focus in on the talent, but have the background out of focus. Also, it's possible, stop this, I can actually add a light. So I grab the reflex, put that in the environment. Now, if I click on that light, I can like background. And again, the beam pattern matches the actual product. I'm doing narrow beam and we do that. So that's kind of how this kind of tool set would work. You'd be able to pull up any one of a number of lights, set them up here. After you virtually applied them and used them, then you could take the same environment on a hard set, and with the same controls, you should get a similar effect. All right. With that, are there any questions?
I'll read a couple of questions from the Q&A that we have so far, but if folks have other questions, please feel free to, you can either raise your hand, it's a relatively small group, so we can do that, or I'll also read questions as they come into the Q&A. So Dominic had asked about the visualizer, but that everything you were seeing was part of Unreal Engine, right? Chuck, you're not showing any other software? Great.
All of that except for the beginning where I did the 3D models. I'm more familiar with SolidWorks, so I use SolidWorks. Maya is actually the most popular tool in our industry to do 3D modeling.
And Dominic has a follow-up question. As a lighting programmer, this seems pretty intense. Any online video tutorials you might recommend to start learning about Unreal Engine and using it as a visualizer, as a tool?
They have a great, if you're willing to take the time, they have an excellent online video course. So when you sign up and you download the program, they have a series of video tutorials where you get the projects. And I had not used Unreal Engine as of, I think, 4 months ago is when I started to learn it, because I saw that it was becoming important for our industry. And I just started taking the tutorial classes, and they have topic after topic, kind of walks you through it. I think it's a little bit intimidating to start, but it's such a valuable tool set to pick up as our industry changes. I think it's a worthwhile investment of people's time. The other thing is a lot of companies are starting to make add-ons. I've seen several dimmer boards, consoles that are being imported. So I think GrandMA's PC software now can actually access and talk to Unreal Engine. So you could actually run a virtual console inside that environment and control lighting.
So we've got a comment from Daniel that he helped prep the projectors used for Oblivion back in the day at Excel. So we've got a couple of people who are actually on that show in the audience. And then
that was a fantastic. I thought that show visually was way ahead of its time. It did such an excellent job. You know, I look at Mandalorian and these other shows. I think Claudia Miranda and the job they did on that program really kind of set a standard for people to follow.
And then I've got a question from an anonymous. What are the cost ranges of building the smaller set and the larger set? So when you're looking at the production hard costs of putting together these virtual environments, what do those look like?
Great question. So today, most people, here's some rules of thumb on virtual production. Depending on the resolution of the LEDs you get, the pitch, the spacing LED to LED, decides how close or far you can be from the wall when you shoot. So the rule of thumb is 1 meter for every millimeter of pitch. So in the case of Mandalorian and a couple of other productions that we've been, other productions that were involved with, we were involved with Mandalorian, the pitch chosen was 2.6 millimeters. That means you have to be about 12 feet away from the wall when you're shooting. So you got to get a wall big enough that if the talent is 12 feet, you know, if the camera is more than 12 feet away, you've got some space to work with. LED wall costs about $4,000 to $6,000 per square meter. So it's always sold in half meter squares, right? So a meter's like 40 inches by 40 inches. So 40 inch by 40 inch section is going to be $4,000 to $6,000 depending on the quality of product you buy. That's a rough price range. But then you have to put the rigging around it and the computers that drive it. And so that becomes the non-trivial part of the expense. So a good example of the stages I pulled up in the presentation. This one, which would be 46 feet wide and 16 feet tall, takes 140 square meters. And if you were spending $5,000, that would be $700,000 for this environment, just the wall. And then you go here, you're 390 square meters. That's over twice as much. And a full volume, this kind of size is going to be several $1 million just for the panels. That's without the rigging, without the control work.
So we've got a question about Unreal Engine, and my dog is barking in the background. Is there a possibility to simulate original camera sensors and lenses with Unreal Engine? So how granular can you get? Yes.
So when you enter Unreal Engine, you can actually specify the speed. You can specify the frames per second. You can specify the focal length of the lens, and then they even have the ability now to calibrate a real camera so you can get the distortion map. So it actually understands that you have to, when you use a real camera, there's going to be a distortion map involved. So those utilities already exist, and they're continually improving this product for virtual production. So I think we're going to see a lot more with camera calibration to the virtual world. That's been growing really quickly.
And then I'm looking at, there's one more question. Brian, I'm going to try, I'm not sure I quite understand your question, but I'm going to try. So is there, what I think you're asking, Brian, is there a way to integrate, if you're on a virtual set, you're running Unreal Engine on a machine, is it, can it work on devices like an iPad or a iPhone? Similar, if you think about a console, you can have an intermediary sort of control device that you can walk on a set and control. So can you do Unreal Engine with a similar kind of idea?
Yes, they absolutely have that. The big challenge is, though, I don't know if you saw, there's a Fortnite lawsuit with Apple and Epic, this battle they're going through, where they started selling Apple products, I guess, through the Fortnite website without going through the App Store. So there's a bit of a conflict right now between Epic and Apple. But that being said, yes, you can absolutely hold with an iPad. You can absolutely mimic the screen and control using an iPad. The other thing really cool, if you have an iPad Pro, especially the new one that has the better motion sensing, is you can use it like a virtual camera, and you can walk. So you can actually draw your set in Unreal Engine, and then tell the iPad to act like a virtual camera, and you can walk around your room and it looks like you're walking around the set. And it'll actually show you where you are in the set and show you what the environment is. It's crazy.
That's amazing. All right, cool. Brian clarified, so that was what he was asking. Awesome. So yeah, that right now, that is all the Q&A we have. If folks have other questions, please do put them in that section. Otherwise, Chuck, we've got like 15 minutes. Is there anything new that you are excited about that you want to talk about?
Something else I'll mention. So I think what we're going to see is this in the next couple of years. We're already working on a product called Stage Links, and GMX has been a great standard. It's based on RS-45, which is basically the electronic equivalent of a teletype kind of standard. So super simple, super robust, but very old technology. And what we're seeing is a push, and all of our new fixtures are going to come out with Ethernet ports on them and Ethernet Wi-Fi. The big advantage of Ethernet is error checking, packet checking. And what that means is if you ever notice when you use a web browser or anything over Ethernet or over in the internet, which is the same protocol, you never get like scrambled data. You may not get the data, right? If your connection's bad, you just get nothing, or you get it perfectly. You never get like the wrong text or the wrong message. And the reason why is every packet has error checking. So it basically says, if you didn't get this total amount of information and it doesn't match up this way, throw it away and I'll resend it to you. So what that means is when you go to Ethernet on stage and the lights are talking Ethernet, you don't get those missed bits and some of the things you see with DMX where lights all of a sudden get strange and flaky, you don't know why. So either the lighting controls are getting there or they aren't. And then you can also run much faster and you can sync it with video. So what we're seeing is a move towards Ethernet as the control network on stage in the future displacing DMX. That doesn't mean you have to be doing virtual production either. It just means you use all the consoles basically support ArtNet and ACCN already. You just have an Ethernet network that runs in parallel. So RAPAC does already, and there are several products where you can easily convert ArtNet, SACN, the Ethernet packet, and DMX King, that's a great one, where you can convert it into regular DMX at the light. And we think, that's probably the big next thing that we all want to work on is starting to move to Ethernet networks on stage to replace, these long DMX daisy chain routes.
We've got one more question that came in about virtual set work in Chicago. So I can speak to that a little bit, Chuck, unless you have a.
Oh, please go ahead.
So there are not a lot of companies that specialize it that are based in Chicago. We have had shows that have come in that have done work like this. I am entirely blanking on the name of the show, and it's too bad because they were here last year during, I think it was Station 11 did a digital stage here last year. So some of the productions that come into town, they absolutely have done this and the work is being done, but the companies that are developing, it's Utopia that did that. I just got a message. So Utopia last year did a virtual stage. So there's definitely the work is being done in Chicago, and it would be just as wise for a technician in the area to learn this and be up on it. In terms of companies that are developing it, those are mostly, as far as I'm aware, those are mostly on the coasts. So, but yeah. Otherwise, any other questions? Please keep them in, put them in Q&A. Otherwise, we got about 10 minutes left. So, could you repeat that last answer? Oh, sure. Yeah, I can. I'll put a follow-up. We're putting a follow-up email together for this class that's going to include a couple of links and some data. And Daniel, I'm seeing your question. I'll put some more information about the digital work being done here in Chicago in that email as well. Perfect. All right. Well, I think we're all set to wrap a little bit early. Chuck, if you've got any final ideas, otherwise we can shut it down.
Ned, thanks for letting me do that.
No worries, and I'll send out those videos in that follow-up email. I'll coordinate with you and get those so I can send those to everybody who was in the class.
Yeah, absolutely.
Perfect. All right. Well, thanks so much, Chuck, and thanks everybody who was here. And looking forward to. We're almost at the end of today, but then tomorrow we've got another full day of classes. So hope to see a lot of you there.
All right. Thank you.
Thanks, folks.
Bye.